Okay, so Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem, and then we are going to do some coding work. And the second goal is to see how we should behave in a real interview. So let's get started. So remember, in the real interview, the first step is always try to understand the question. If there is anything unclear, please bring up the question to the interviewer, and at the same time think about some edge cases. So let's take a look at this question. So it's called subtree of another tree. So given two non-empty binary trees S and T, check whether tree T has exactly the same structure and nodes values with the subtree of S. So a subtree of S is a tree consists of nodes in S and all of these nodes descendants. So tree S could also be considered as a subtree of itself. Okay, so let's see the example. Let's see, for this example, you're going to return true because the tree T is equal to the subtree, which is the left subtree here. And for example 2, there's no subtree within S equal to T. Okay, so I think the problem is pretty clear. Let's see how to solve it. So I would say we could use some recursion to solve this problem. Like for each node within the S, we try to see if it has the same structure with T. So for example, starting from 3, we see if with the root 3, if the tree is the same as T, and we also see with the node 4 as a root whether the tree is the same as T. So on and so forth. We try every node within S. So we try every node within S, make it as a root, and see starting from the root if the structure is the same as T. So having said that, the solution is using recursion and treat every S as a root and compare the subtree from that root with tree T. So the runtime is going to be O m by n. So m is the size of the tree S, and it is the size of the tree T. So that's pretty much it. Let's do some coding work. So for coding, we care about the correctness of the code and the readability of the code, and also don't be too slow. So let's see. I would say if S is equal to none, or so I'm thinking about if S or T is a empty tree, it could be a edge case. So let's see. I think we should be able to cover this, our general algorithm. Let's define a function. Let's call it is same. So is same means we pass into tree node T. So if they are both none, so if S equal none and T is equal to none, then we are going to, of course, return true. Otherwise, it means S is not equal to T, it's not a none, or T is not a none, or they're both not none. So if S is equal to none, or T is equal to none, or S dot value is not equal to T dot value, then we are going to return false. Otherwise, it means they are the same, then we are going to return true finally. So we are going to say okay, if is same S and T, then we are going to return true. Otherwise, we are going to say return. So if it's the same, then it's going to return true. We need to see the left subtree and the right subtree. If s dot left is not equal to non-pointer, so if t is a non-pointer, then potentially it could be okay. Alright, so I think so this one is also like a recursive function, I think. Yeah, so we need to define something. So if s is equal to none, and t is equal to a non-pointer, then we should, so let's say if we do this, first of all, if we call is same, then should already return true for that case, like or none. So if it not return true, like either s is equal to none or t is equal to none, or the value is not the same, I'll say if s is equal to a non-pointer, then it means it's not the same, then we are going to return false. Otherwise, we need to return is subtree s dot left t, or is subtree s dot right and t. So let's take a look at this one. So first of all, we compare starting from the root node s if they are the same. If yes, then return true. Otherwise, they are not the same. When they're not the same, then it means that s and t are not none at the same time. But what if s is equal to, so if s equal to none and t is not equal to none, then we are going to return false. If s is equal to, okay, so if this is the same as, if it's same, return false. That means s and t cannot be none at the same time. So if s equal none, then we are going to return false, which is good. And then we are going, and for sure we can guarantee that it has a left and right child. All right, so let's take this example to do some sanity check. So for testing, we go through a simple test case, do some sanity check about the logic, and at the same time we think about we will communicate with the interviewer, explaining how this piece of code is going to work. So let's start from this one is the same. So when we compare, so from here it's okay, from here it's okay, here is okay, but when we compare the children's for this node, it's not good. So okay, so I think we are doing something wrong for is same. So it's same if it is wrong. Okay, so it should be is same s dot left t dot left and is same s dot right and t dot right. So is it possible that so this means after those two ifs, it means both of them are not none. So I think it should be good if we do this comparison. All right, so I think after we fix this bug, and after that I think we should be good here. Let's give it a shot. Alright, so it's good. Let's give it a submission. Alright, so I think we should be good about the solution for this question. If you have any question about this solution or about this puzzle, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.